my channel. My name is M.R.E.ngineering and today I'm going to talk about an introduction to automotive electrical systems. I know that some guys back off when they face an electrical issue on their cars, and the primary objective of this video is to provide you with simple technical information that reinforces you against a situation that an electrical issue can make you feel embarrassed. Surely you know that automotive electrical systems and electronics are evolving and expanding very fast, and even though in the past electrical system of a car was summarized into ignition system and maybe headlights, but modern cars of today have hundreds of electrical components and a massive amount of wires. And of course, to understand these electrical details, you need to spend a lot of time to pass courses relating to circuits and how transformation of electrical power into movement happens. But I think if you know some laws and scientific facts, you can have a general idea about these electrical systems and the circuits that are used on your car. Generally, when we are talking about electricals and electricity, we are talking about circuits. And if you have a circuit that contains a source of electrical power, you can expect that electricity flows into that circuit. This source of power can produce electrical current in different ways: chemical reaction, magnetic induction, applying pressure, using heat, and even friction. But before I talk about any electrical system or circuit, let me to talk about some scientific facts. What do you know about the atoms? Don't worry, I don't want to talk about rocket science. It's just a tiny little atom. An atom is defined as the smallest part of a chemical element that still has all the characteristics of that element. Okay? Each atom is constructed of electrons and nucleus, and electrons with negative charge are fixed around nucleus with positive charge, and these negative and positive charges attract each other so the atom can retain its balanced state. The critical point here is that the electrical current happens when that source of power forces electrons to move in the circuit. In other words, to have the flow of electrons that is the same as electrical current and electricity, we need to have a demand on the other side so the electrons start to move to that other side. This demand happens when a positive charge on that other side causes a potential difference or a force on the electrons to move. This force in electricity is known as voltage, and its magnitude is expressed in terms of volts. Also, there's a close resemblance between an electrical circuit and a river or creek. Both of them have flow rate. In creek, we have water flow rate, and in electricity, we have electron flow rate. But this flow rate in electricity is known as current and is expressed in terms of amperes. Now, imagine that we put a very big stone in the creek. This action makes a restriction for water flow. This restriction in electricity is known as resistance and is presented in ohms. This resistance can be caused by a dedicated resistor, consumer, or even a back connection in the circuit. But different elements show different electron flow rate when we use them in a circuit with a certain magnitude of voltage. This happens due to different number of electrons in the outer layer of the atoms that is known as valence ring. In fact, the lonely electrons in this outer layer have a loose connection to their atom family, and they get easily detached from that and flow in the circuit. For example, metals like gold, silver, and copper have only one electron in their outer ring and valence ring and easily can lose that one, and they are known as very good conductors. And the iron has 2 electrons in its outer ring and is known as pretty good conductor, and elements like carbon and silicon have 4 electrons in their outer ring and have a resistance to lose them, and they are known as semiconductors. And materials like rubber and plastics don't let their electrons to go away, and they are known as insulators. Now I want to go from macros to the macros. I think discussion from here would be more sensible for you. In a gasoline car, 2 main sources of electrical power are used: the battery and the alternator, that is an electricity generator. I talk about these components and their functions and characteristics in different and separate videos, but today you just know that battery uses chemical reaction and the alternator uses magnetic induction and rectifier to produce that electromotive force or a DC voltage to have that electrical current or flow of electrons in the circuits. But why two different sources of electrical power are used in a car? The reason is very simple. When the car is off and the alternator is not working, we need to use chemical energy of the battery to start a car. But battery needs to be recharged. So when the car is working using power of the engine and a belt and pulleys, the alternator produces an electricity that its voltage is about 2 volts more than the 12 volts of the battery to recharge that. In fact, it's the alternator that is charging the battery and at the same time supplies power for electrical components and consumers. Also, the battery works as a backup for the alternator, and also it acts as a stabilizer to even out damaging voltage spikes that happen in the circuits on the alternator. And when the car is off, the battery is used to operate accessories and lights. But as I said, the electrons flow from negative side of the connection to the positive side. So we know that electrical current flows from negative side of the battery to the positive side. But based on a conventional theory and the way that technicians think, the electrical current flows from positive side of the battery to the negative side. In fact, it doesn't matter what is the electrical current direction. You just need to know the nature of the current and its effects. In this video, our assumption is that electrical current flows from positive side of the battery to the negative side. In this diagram, you can see a very simple circuit that shows how the alternator and battery are connected to each other and to the loads in a car. The load in this diagram can be a motor, a light, a solenoid, or ignition system, but all of them are designed to use the applied voltage and flow of electrons to do the intended function. For example, an incandescent light diffuses light when it heats up as a result of passing electrons. And also, by reversing polarity of a circuit, we can reverse direction for rotation of a motor. And using this law, we can use a single motor to move the windows of a car up and down. But before I talk about any specific electrical component and system, let me talk more about the circuits. Maybe you know that there are two types of electricity. AC type that fluctuates in direction and its magnitude is expressed in a kind of mean voltage or current known as RMS, like household electricity of 120 or 220 volts. Another type of electricity is DC type that is mainly produced by battery and battery chargers, and it has a direct and constant magnitude and direction. And of course, most of the cars work with a nominal 12 volt DC voltage. But when the electrical current starts to travel from positive side of the battery, it seeks a path to the negative side to complete the circuit. Designers put the switch and consumers in series or parallel configurations to use and control that electrical current. In this diagram, you can see a very simple circuit that can be used, for example, for tail lights of a car. As you can see, if one of the lights in this circuit burns out, still there's a path for the current to go to the negative side that is also known as the ground, and I talk about that in the following. Also, consider that each lamp in this circuit is a load, so the current can't freely flow to the negative. In other words, there's a resistance in the circuit. Now, imagine that a short to the negative or the ground happens for this circuit. In this case, the current can flow to the negative side without any resistance, so a high current can flow in the circuit. This high current is very dangerous. First, it starts to heat up the wires that it is flowing through, and then with more and more heat, it can result in fusion or even a fire. But if the circuit continues to pass this high current, it can result in severe damage to the battery and even an explosion. To prevent these damage to the wirings and components, every circuit needs to have at least one fusible link in that, so it breaks and opens when a short to the negative side happens to that circuit. Also, always to protect the battery, there is a single or a few main fuses with high amperage capacity just after the battery. But our circuit is still mature. Components that demand high currents require larger diameter wires in their circuits, but you cannot use these high current wires in a circuit that the switch is controlling that in series. The reason is very simple. It's because the cost of routing these larger diameter wires to the switch and then to the consumers increases, and also sparks and arcings that these high currents make when the switch opens and closes will damage the contact points of that switch. And remember that many of these switches are located inside the sensitive ECUs. Now, to solve these problems, we can isolate the switch from the main circuit and use thin wires to connect that to a relay, that when this relay is activated by the switch, the coil inside that makes a magnetic field that connects an internal switch for the main circuit. So this relay makes our design more optimum and efficient, and our circuit in simplest form turns into this configuration. In this circuit, the switch can be a simple heater switch, a multifunction headlight switch, or a main ignition switch for starting the car. For the starting system, the relay is mounted on the starting motor and is known as a starter solenoid. About the starting system, I'll have another video to talk about that, but if you can't find the starting motor on the engine, you can see that there are two wires are connected to that. The thin wire from ignition switch and for commanding the start, and the thicker one that is connected directly to the battery to draw a high current during starting. But most of the relays are compacted with the fuses in a few junction or power distribution boxes for sake of simplicity and saving wirings. These boxes are located inside the cabin, under the dash, or in the trunk, or under the hood next to the battery, or maybe other places on the vehicle. Also, you can find relays or fuses out of these boxes near the consumers, like some air conditioning system or radiator fans. But if they are contained into a box, usually their usage and rating are marked on the cover of that box. Now I want to talk about negative side of the connections or ground side of the circuits. We can say that on all the vehicles, when we are talking about the ground, we are talking about negative post of the battery with zero reference voltage. And remember that almost all the body of the car is connected to the ground. So when we want to connect end of each circuit to the negative or ground, we don't need to connect that directly to the negative post of the battery, and just connecting that to the bare metals of the body is enough. This ground connection is done by connecting ground straps between the battery and the body. Also, since the powertrain is insulated from the body by rubber mounts or bushings, and there are kind of insulators, so at least one ground strap is required to connect the powertrain to the negative. Okay, these were just very simple fundamentals for circuits, but by understanding these fundamentals, you can have a general idea about the whole electrical systems and circuits that are used on your car. On the car and in practice, a circuit can be consisted of many of these simple circuits, and the whole electrical system is intertwined wires, fuses, and relays that are connected to each other in series or parallel circuits to have that desired output. And remember that a circuit can have many fuses and relays on that, and also a fuse or relay can be used by multiple circuits. In fact, the creativity of designers is very critical for simplicity and effectiveness of the circuits. In the factories, to save the cost of production and optimize occupied space by the wires, designers put the wires side by side and route them together. These sets of wires, if get grouped together, are known as wiring harness. In a car, there are a few main and big wiring harnesses, and they are used in engine compartment, under the dash, on the floor, and maybe under the roof. Also in the cars, there are simple wiring harnesses that are used to feed the electrical power to components that are far or need a special routing. An example is lighting system that usually has a simple wiring harness. Also, in some cases, high current wires are routed separately to reduce electromagnetic noise on other sensitive circuits. This noise returns to a scientific fact that states that when a current is passing through a wire, causes a magnetic field around that wire, and magnitude of this magnetic field is proportional to magnitude of the current that is passing through that wire, and change of this magnetic field can induce a current in the conductors around that wire, and this unwanted current in this case is known as electromagnetic noise. Well, I don't want to confuse you and go beyond joule tolerances. Now I come back to our main subject. Also, manufacturers use flexible conduits over these wire harnesses to protect them against impacts and abrasion, and also at the end of the wires there are connectors to connect them to the components and junction blocks. But again, talking about these connectors, their design and types is not subject of this video. Also, among the wires in the wire harnesses, there are some wires that are used to transfer data between modules over some data bus networks. In a car, networks are used to connect the modules and computers to each other, and since since a major part of controls and circuits are related to these computers, that using solid-state electronics can reduce a massive amount of wires and increase the speed and reliability of the systems. For example, for a high-speed CAN network, these wires are coupled and twisted to each other to reduce electromagnetic interference. About the networks and different protocols that are used in a car, I'll make a few videos in the future, but those videos are very technical and don't fit the owners. Also, manufacturers prepare some manuals that show the whole circuits, components, modules, pin number of connectors, and even color of the wires for each system. And of course, using these manuals require experience and training, but a qualified technician can use them easily to follow the circuits and diagnose and fix the electrical problems. Now, I want to review the electrical systems and their operation from the time you sit in the car and start to move until you stop and turn it off. But please note that due to difference between designs and level of technologies, systems and circuits can vary from car to car and model to model. But I try to talk about them in general and most common types that are used today in automotive industry. When the car is off and even the key is out of the car, the battery voltage is present and can be used. Some systems and components use this electrical power when the car is off and is resting parking state. One of these systems is security system that is vigilant for any intrusion, and also engine control module, like many other modules, is receiving constant battery voltage to retain some data in memory and also perform some leakage tests and calibrations even when the car is off. Normally, a typical car consumes about 20 to 50 milliamp current during parking time. Now, when you are sitting in the car and before you insert the key inside of the ignition switch, some systems are active and can be operated. These systems are like interior lighting, headlights, flashers, and the horn. In modern cars, these systems get activated by the relays that are controlled by an ECU called Main Body Control Module, or BCM. Now we can say that these systems don't have the ignition switch and their circuits, but they are always protected by at least one fusible link after the battery. Then when you insert the key inside of the ignition switch and turn it to ACC position, some accessory systems like clock, radio, and lighter get activated, and also in some cars, systems like seats, air conditioning, and even windshield wipers are incorporated into this ignition switch position. Next step, when you turn the ignition switch, is on position, where you can hear a noise from the fuel pump indicating that it has activated to get primed. I jump this key position to talk about that after the starting. Then, when you turn the ignition switch to the end position, that is protected by a spring so that the key doesn't stay there. When you release that, electrical power is fed to a starter relay to crank the engine. And at the same time, engine control module receives ignition feed to activate the fuel pump relay and drivers for injectors and ignition coils only if it receives permission from the security system and signals indicating that the crankshaft is rotating by the starter. In this condition, if the air, fuel, and sparks be present, car starts and keeps running. Now, you can release the ignition key and it returns to the run position and the starter disengages from the flywheel or flex plate. But engine continues to run as long as the ECM receives crankshaft rotation signals and enough air, fuel, and sparks are provided. Now we can say that in run position, almost all the electrical systems and components of the car are active and are ready to be used. In this state, if you turn the ignition key back to ACC position, ignition feed for engine control module terminates and all the relays and drivers of the engine will shut down and car turns off. Now you can understand that how much role of the engine control module or powertrain control module, known as ECM or PCM, is critical for starting and running the engine. But the ECM is not the only module that is used in a modern car. As I said, there's at least one network that the ECM is working on that. And if there's more than one network used in a car, always the ECM works on the high-speed one. For designs that more than one network used in a car, usually a module works as the gateway to translate different messages between different data bus networks for optimum communication. Also in the cabin, most of the accessories except multimedia work on low or medium speed networks. Some designs use a single wire data bus for low-speed networks. So, for example, for an exterior mirror that doesn't have any camera or radar on that, many functions can be accomplished using just 3 wires. A battery positive feed that is provided by a relay that is controlled by a module, a constant ground connection, and a single wire communication line. These 3 wires are connected to a slave module inside the mirror to accomplish the commands that are sent from a master module. I think going further more into details of electrical systems in this video is a big mistake and makes you exhausted. I explain different electrical systems in different and separate videos, and if you follow my channel, you can watch them in the future. In the following, I want to talk about some technical tips that can help you to maintain and use your car electrical system better and more efficient. Please note that I talk about each case in general because you are not supposed to do any service work on your car electrical system. And remember that electricity is a silent and invisible potential danger, and your false self-confidence can result in your property or body damage. Imagine that you have just sat in your car and command your car to start. In this moment, a no start engine can be a very big disappointment. This problem can have many reasons, and through a study of each case requires an exhaustive video that I'll make them in the future. But today, I want to talk about this problem in brief. Already, I explained the process of starting a car step by step, and if you follow those steps very carefully, I think very likely you can find the reason that your car is not starting. Now, I'll review them again. First thing that you need to do when you want to start a car is that you follow the exact procedure that is indicated in your car owner manual. For example, if it requires that you press the brake or clutch pedal to close the circuit or send a signal to an ECU, you need to do that. Then, when you command the engine to start, engine control module asks for immobilizer permission for starting. So, if you saw that the security light on the dash is flashing, it means that there's a problem with the system and probably you can start your car. Generally, when you want to start a car, always carefully watch the instrumental panel when you turn the key to the on position. If no light on this panel is lit, probably you have a problem with the battery or its connections. But if you have some lights on this panel, but the check engine light is not lit, likely your ECM is the culprit. In all of these cases, you can't hear any noise from the fuel pump indicating that it's activated to get primed. But if the security system grants the permission and engine control module is working properly, but the starter is not turning or it doesn't function properly, other than the starter, maybe you have a weak battery or there's a problem on battery posts or there's a bad positive or negative connection on the starter. Also, engine mechanical problems sometimes show the same symptoms. But if the engine cranks but it doesn't start, maybe you have a problem with the fuel, air or sparks and you need to visit a service shop. Also, maybe one of the electrical system or accessories of your car is not working. For these issues, you can refer to circuit principles that I already explained, and very likely you can find the reason. Sometimes a loose ground connection is the cause, or maybe a fuse under the dash or in engine compartment fuse box has blown. But always be cautious about the fuses when you want to replace them. The reason that the fuse has blown can be a short to the negative side, so when you want to insert the new fuse inside, it makes a spark and blows immediately again. So before you replace the fuse, always try to find the reason of the blow and always use the fuse with the same amp rating as the original one, because using a fuse with higher amp rating can cause severe damage to the components and even can make a fire. And maybe on your car you have found a damaged wire that needs to be changed, or for any other reason you want to extend a wire. My recommendation for this issue is that you never ever use a wire with less diameter than the other wires that are used on that circuit, because with less diameter, resistance of the wire increases. That can generate excessive heat, fusion of the wires, and then can lead to a fire. And remember that when you want to work on electrical systems, wisely remove the battery negative connection, or to avoid ECU's memory loss, you can neutral that system by removing the related fuse for that circuit. Not following this precaution can cause sparks, blown fuses, and then can make a fire. And never do anything to the wires that are connected to those yellow connectors, because yellow connectors are mainly used by the airbags, and manipulating them can ignite the airbags even if the car is off and you have removed the battery negative connection. And also a frustrating problem with the cars is a drained battery every morning. 3 main reasons can cause this problem. First, maybe the battery needs your attention, or probably it's dying. Second, maybe the alternator doesn't work properly, or its drive belt is loose. And third, maybe there's a parasitic drain from one of the electrical system or accessories of a car that is drawing current from the battery with amp rating that is less than the rating of the fuse that is protecting that circuit. Diagnosing all 3 of them requires experience of working with digital multimeters and test lights, but for the 3rd one, I have a simple solution that the owners can do, and sometimes it works. To do this job, you first need to stimulate the closing of the doors and hood by deactivating the door jump switch, and then wait a few minutes so all the modules go into sleep. Then use a low amp fuse and eventually I decided to cut the technique out of this video because I thought that everybody could do that properly. That might end up in damage to the sensitive modules on some models. Also, if your car has started and during engine on condition, you saw that the battery light on the dash is illuminating, it indicates that there's a problem with the battery or charging system. Also, on some cars and models, there's a safety switch that is also known as inertial switch, and it is used to cut the electrical power for fuel pump in an accident or rollover. Also, malfunctions and hard impacts can open this switch. So, if you have just passed over a pothole and your car has turned off, this switch can be the culprit. Sometimes, simply pushing the metal ball on this switch can solve the problem. And another tip is that if you have a burnt lamp in your car, refer to your car owner manual for instructions for replacing that with new one. But if aftermarket headlight system is used on your car, refer to a qualified technician, because some high voltage systems can shock you dangerously. Also, if you have a hybrid or electric car, don't touch those orange high voltage wires or cables or the components that these wires or cables are attached to, even when you think that your car is off. At the end, I recommend you to keep a flashlight or a DC LED light in your car, to use that in emergencies by connecting that to the battery. I hope that this video was useful and informative for you and worth the precious time that you spent for watching that. Please subscribe to my channel if you like, and press the bell icon to be notified if I have a new video on my channel. Bye.